So today our lesson is about freezing point depression.
The freezing point of a substance is the temperature at which it changes from a liquid to a solid. For example, water freezes at 0 Celsius. But what happens if we dissolve something like salt or sugar into water?
The freezing point goes down. And this is called freezing point depression. Why does this happen? Imagine water molecules as dancers holding hands in a circle. They need to join hands perfectly to freeze into a solid ice structure. Now, when we add a solute like salt, it's like putting obstacles in the middle of their circle. The water molecules cannot join hands easily, so freezing takes more time. So there are three main factors of freezing point depression.
First, the type of solute. Some solutes, like salt, break apart into multiple pieces that turns into ions when dissolved. This creates more particles that disrupt freezing. Second, the number of solute particles. More particles mean more disruption to the freezing process. Third, the solvent's properties. Different liquids like water or benzene have different freezing point depression constants. T sub F is equal to K sub F multiplied to M multiplied to I. T sub F is the drop in freezing point. K sub F is the freezing point depression constant that depends on the solvent. M is the molality of the solution. This is how concentrated the solute is. I is the Van Hoff factor. How many particles the solute produces in a solution.
Let's solve a simple problem to make this clear. What is the freezing point of depression when 155 grams of iodine crystal are added to 1,200 grams of benzene? Given 155 grams of iodine crystal and 1,200 grams of benzene. Step 1. Calculating molality. First, we convert the mass of iodine to moles using its molar mass, 254 grams per mole. 155 grams iodine times 1 mole iodine over 254 grams iodine equals 0.6102 mole iodine. Next, we convert the mass of benzene to kilogram. 1,200 grams benzene times 1 kilogram over 1,000 grams is equal to 1.2 kilogram benzene. Finally, we calculate the molality. Molality is equal to 0.6102 mole iodine over 1.2 kilogram benzene is equal to 0.5085 molality. Step 2. Calculating freezing point depression. The freezing point depression is calculated using the following formula. Substituting the values. A sub T of F equal 5.12 Celsius over molality times 0.5085 molality equals 2.61 Celsius. Therefore, the freezing point of the benzene solution is depressed by 2.61 Celsius. Let's review what we've learned. First, freezing point depression happens when a solute is added to a solvent, lowering its freezing point. Second, the amount of depression depends on the number and type of solute particles.